Welcome to Study Loop.
This is the answer to Chapter 13, problem number 29 from the Smith Organic Chemistry textbook. And so in this problem, we are asked to propose two possible structures for a hydrocarbon having an exact mass of 96.0939 that forms ethyl cyclopentane upon hydrogenation with H2 and palladium on carbon. Okay. And so 96.0939 or 96.0940, as I've written it here. So we're going to need to figure out what molecular formula that corresponds to. But fortunately, we have a big clue in the fact that we need something that's going to be hydrogenated to ethyl cyclopentane. And so because we're talking about hydrogenation, basically this is telling us that we have ethyl cyclopentane with a double bond in it somewhere. And so all that we need to determine is it one double bond? Is it two double bonds? And so that's where we're going to use this exact mass. So using the table from this chapter and some math, we should be able to arrive at a molecular formula of C7H12, which is going to have an exact mass of 96.0940. So the problem actually asked for 96.0939. So we're very, very close there. So this is going to be the correct molecular formula, C7H12. And so we could do an HDI here. And that's going to tell us how many double bonds we have. So 14 plus 2 is 16, minus 12 is 4, over 2 is 2. Okay, and so obviously we have one ring already from the cyclopentane. And so we have one more degree of unsaturation. So we're only going to have one double bond. So our structures that we're going to propose are going to be basically this ethyl cyclopentane with a double bond anywhere in the molecule. So here are two. We're only asked to propose two. Obviously, you could propose more than two. You could keep putting the double bond in different places around the ring, but these two are fine. And so that's the answer here. And that's the way to approach this. Understand that the hydrogenation clue is a big clue that basically tells us that we are just looking for ethyl cyclopentane, but with one or more double bonds in there somewhere. And then we can use the exact mass to figure out the exact formula that we're looking for. And doing an HDI will tell us how many double bonds we need to account for in the starting material. And in this case, it's just one double bond. And so these two structures that I've drawn are fine. And as I said, there are several others that you could propose just based on where you want to put your double bond. And that's the answer to Chapter 13.